In this video, I'm going to be solving trig integrals. Now, I'm not going to be solving the easy integrals like just the integral of sine or the integral of cosine. No, those are calculus 1. You're in calculus 2 now, and the ones we're going to solve are sine to the power of 3. This is an example. Maybe I'll use x instead. This is another example, tangent to the power of 3. We'll work on this, or maybe just sine to the power of 2, or cosine to the power of 2. All right, and I'm going to be showing you some basic trig identities that you need to know first. These will help you a lot because in order to solve those trig integrals that I just showed you, maybe I'll just leave them on the screen. In order to solve these, you need to use trigonometric and algebraic manipulation in order to solve these. So you need to manipulate sine to the power of 3 into a state that you can integrate, right? Sine to the power of 3, you can't integrate it in that state alone. So you need to manipulate it. You need to manipulate some function in order to do that, which I will be showing you in this video today. So first things first, there's going to be a couple identities that you need to know. This one will help a lot. Sine to the power of 2 and cosine to the power of 2 is equal to 1 minus cosine of 2x over 2. And cosine to the power of 2 is 1 plus cosine 2x over 2. Now, the thing about these is that, well, you can't integrate sine squared, right? There's no u sub that you can possibly do. There's nothing they can do with it besides just using this identity, really. So if you turn it into this form, well, technically, 1 minus cosine 2x over 2 is equal to this, right? You can separate the upper function terms. You can separate the numerator terms to get 1/2 minus cosine of 2x over 2. Well, this is integratable using u substitution or just intuition, right? And that's the same for cosine squared. These are pretty important identities. There's also the Pythagorean identities for trig functions. Sine squared plus cosine squared of x is equal to 1. Sometimes you're going to see a sine squared plus cosine squared is equal to x in a trig function. You would just completely eliminate it into a 1. Right? That's going to help a lot when you're solving for the trig integrals. And also, you can divide each term by sine squared. Right? If you divide each term by sine squared, what do you get? Well, if you divide sine squared by sine squared, you get 1. If you divide cosine squared by sine squared, you get cotangent squared. Right? Cosine x over sine x is equal to cotangent, if you didn't remember this. And sine of x, the reciprocal of cotangent, is equal to tangent of x. So these are important identities as well. You're likely going to have to use these when you're solving trig integrals. There's a bunch that you can do, but it just requires practice in the classes that you're doing. If you divide 1 by sine squared, as I've defined everything else by sine squared, you get cosecant. Right? 1 divided by sine squared is cosecant. All right, what if you divide everything in this trig integral? What am I saying? I was just reading the top part. This trig identity, this Pythagorean identity by cosine. Well, if you divide everything, all the terms by cosine here, cosine squared, more specifically, you get sine squared divided by cosine squared, which is equal to tangent. Cosine squared divided by cosine squared is 1, and 1 over cosine squared is secant squared. So these are going to be useful, especially when you're doing trigonometric substitution. That's the next thing you're likely going to be learning. I'm not sure if a lot of universities teach that anymore. Mine did, so I'm going to teach it. And I probably would have taught it even if mine didn't teach it. But trigonometric substitution, this is the core foundation of trigonometric substitution. It's like u sub, but we use trig functions instead. But this right here, memorize it. You know, all you really need to memorize is this, and then you can derive the rest from this top formula. You also need to know that from that formula, sine squared, I don't know why I erased it, sine squared cosine squared is equal to 1. You can set it so that sine squared is equal to 1 minus cosine squared. So this will be very helpful. And cosine squared is equal to 1 minus sine squared. Right? I just simply move these terms onto the other side of the equation. So these right here can help you a lot when you're solving for the trig integrals. For this first problem, you're going to get something that's super common. Something to the power of 3. Sine to the power of 3, cosine to the power of 3. Both the steps are very similar. Usually use u sub in the end, right? But if you have some decent pattern recognition skills, then once you learn this, you can solve for most of the integrals to the power of 3. All right, let's go ahead and solve this. Well, first thing you can do, you can separate this into sine to the power of x times sorry, what am I saying? Sine to the power of x. Oh my god. Sine of x times sine squared of x, right? This makes sense. Well, sine of x, sine squared of x is equal to 1 minus cosine squared of x dx. Okay, and maybe some of you might think, oh, you can turn sine of x into 1 minus cosine of x. Never do this. Do not turn sine of x equal to 1 minus cosine of x. Maybe I should have said that at the beginning of the video, but never do that. I've seen some of my friends do that in the work, and I'm like face palming myself. But you can only do it for squared sines or cosine squareds. All right, now that you have this, well, you can distribute the sine into everything. So you can distribute the sine into here, so you get sine times 1, which is just still sine, and sine times cosine squared, which is sine of x cosine squared of x dx. Well, per the integral rules, we can separate the integral if it's different, if it has different terms, into terms. So sine of x dx minus sine of x cosine squared of x dx. All right, let's erase the rest here. Let's solve for this integral now. Well, the integral of sine of x is just equal to negative cosine. Right, that's just the trig identity. But we need to solve for the integral of this now. Well, how do you solve for the integral of sine of x cosine of x? Let's separate that to make this more clear for you guys. Well, technically, this is a chain. Does it not look like a chain? Well, sine is the derivative of cosine, with a negative, of course. So what can we do? Well, we can use u substitution. If you see anything that's the derivative of something else inside of an integral, you can use u substitution to solve for your integral, because remember, it's an antiderivative. So technically there was some chain rule going on here, and you can do reverse chain rule, which is u sub in this case. So we'll sub out u for cosine of x, and we'll replace du with negative sine of x dx. Therefore, dx is equal to negative sine of x, du over negative sine of x. All right. Okay, now that we have this, well, we're going to have sine of x times u squared, right? Cosine is equal to u, and d of x is equal to du over negative sine of x. Well, looky here. These signs cancel, and we get a negative here as well. So we need to you need to bring the negative out of the integral so that you get u squared du. Well, the integral of u squared is just reverse power rule, is it not? So you get negative u to the power of 3 over 3, and technically u is equal to cosine, so you get negative cosine to the power of 3x over 3. All right, now that we have this, negative cosine to the power of 3x over 3 is equal to the integral of sine cosine squared. Now here's the thing. There's a minus here, and there's a minus in our answer for our integral. That means these minuses cancel out, so you get a plus here. So you get a plus cosine to the power of 3x over 3, and never forget the arbitrary constant. That's not a calculus 1 thing, that's a calculus 2 thing as well, and a calculus 3 thing. Never forget the arbitrary constant. This right here is the integral of sine to the power of 3x. All right, so for this problem, it's going to be very similar to sine to the power of 4. But we're going to solve for the cosine version. Both of these steps will be extremely similar. So assuming that you have a little bit of math skill, you'll be able to do sine to the power of 4 if you know how to do cosine to the power of 4. So what we can do with cosine to the power of 4? Well, cosine to the power of 4 can be extracted out. Right? So the square can be extracted out, so we get cosine squared, squared again. Well, this is just cosine to the power of 4 using exponent rules. And cosine squared, remember, we covered in the beginning of the video, cosine squared is equal to 1 plus cosine 2x over 2. And the reason why we do this is so that we can have some integratable function. So if we replace 1 cosine squared with 1 plus cosine 2x over 2 squared, we get this. Well, what we can also do next is factor out the 1/4 at the bottom here. Technically, when you square a fraction, you square both the denominator and the numerator separately. So we have a 1 plus cosine 2x squared over a 2 squared. Right? And a 2 squared is just 1 over 4. So technically we have 1 over 4, 1 plus cosine 2x squared. All right, now that we have this, we can use a little bit of FOIL. A little bit of algebra coming back in, and we can multiply 1 plus cosine 2x times 1 plus cosine 2x. Oops, why did I zoom in? Okay, I had to zoom back out. I accidentally clicked the zoom in tool. But 1 plus cosine 2x squared is equal to, well, 1 plus cosine 2x times 1 plus cosine 2x, correct? Well, if we use a little bit of FOIL, an algebra technique that you learned, then you would get 1 plus 2 cosine x. Wait, 1 plus 2 cosine 2x plus cosine squared 2x dx. Don't forget the differential. And let's make more space. All right. I think I can erase everything else. And once you have this, well, you have another squared. Well, technically, the more general formula for cosine squared is equal to 1 plus, let's use u here actually. It's equal to 1 plus cosine 2 times u over 2. So u is the input of your cosine function. Well, if 2x is the input, technically we have a 1 plus cosine 4x here. So we can replace that with our cosine squared 2x. And then now we have something that's even more integratable. So we can integrate these in different terms. So we have 1/4. Let's leave out the 1/4 for now. We just want to find the integral of 1 dx. All right, well, integral of 1 dx is just x. I just gave you the answer there. We have to find the integral of 2 cosine 2x. And we have to find the integral of 1 over 2 plus cosine of 4x over 2 dx. All right, well, let's solve this integral. Integral of 1 is just simply x. The integral of 2 cosine 2x is, oh, 2 is obviously some chain of sine. So the integral of 2 cosine 2x, if you need a little bit of work on u substitution, I'll tell you right now. I'm just going to solve this to save time, but u is equal to 2x for this integral, and you can work out the u sub yourself. But we have sine 2x here. I want to find the integral of 1/2. The integral of 1/2 is just 1/2 x. Let's write x over 2. The integral of cosine to the power of, cosine of 4x over 2 is equal to sine of 4x over 8. Using a little bit of u sub, and again, u is equal to 4x in this case, if you want to use u sub on that for yourself. And don't forget, we're multiplying by 1/4. Right, we have a 1/4 at the beginning here, plus c. So for this problem, we have tangent to the power 3, very, very similar to the cosine to the power 3 and sine to the power 3, but something a little less obvious as before. So let's go ahead and do this. Tangent to the power 3 can be separated as tangent times tangent squared. And what we can actually do with the tangent squared is, remember, 1 minus secant squared is equal to tangent squared. So we can replace tangent squared in this with secant squared. 1 minus secant squared, sorry. All right, let's go ahead and distribute the tangent into your parentheses here. So tangent times 1 is just tangent, and tangent times secant squared is equal to tangent x secant squared x. All right, well, the integral of tangent x is its identity of the negative of the natural logarithm of cosine x. And the reason being is, if you find the derivative of this and then use chain rule, you'll notice that it will equal to tangent. Therefore, the integral of tangent is equal to this. Let's go ahead and write that down then. Save the answer up here, actually. Negative natural logarithm of cosine of x. All right, now we need to solve for the integral of tangent secant squared. Separate that. Technically negative tangent secant squared since we have a minus here. But let's keep that in mind. Let's keep that in the back of our head. All right, what's the integral of this? Well, again, you're going to see some chain rule here. Chain rule. Secant squared is the derivative of tangent. So you can use u substitution for tangent. That's going to help a lot. It's going to make this problem extremely easy if you use u sub. Actually, I'm not going to erase that yet. Let's use u sub, and let's set tangent equal to u. And therefore, du is equal to secant squared x dx, and therefore dx is equal to secant squared du over secant squared. Right. All right. Now what we can do is replace tangent with u. We have secant squared x, and the dx we replace with du over secant squared x. All right. Well, secant squared x just cancels out. So we get u du. Oh, reverse power rule, right? So this is equal to u squared over 2 plus c, of course, but u is equal to tangent. So we have tangent squared over 2 plus c as our integral for tangent x secant squared x. But remember, if we want to put this into your answer, don't forget the negative. So we'll put a negative here, and we get to tangent x over 2 plus c. And this right here is the integral of tangent to the power of 3. All right, let's go ahead and solve for the integral of the secant to the power of 4. All right, first thing we want to do, separate the secant into secant squared times secant squared. Now, okay, this might, like all the steps I've been doing, right? I already worked out the problems beforehand, but you will get a like intuition for how to manipulate the trig functions as you do it more. There's no other way. Maybe if you have better pattern recognition skills than other people, right, you'll learn it faster. But there's absolutely no other way to get better at doing this than just doing more problems. So, go to office hours, maybe ask a professor. If you're taking Calc, BC, I don't know, ask your teacher for more problems, or going online. Ask ChatGPT, for Christ's sake, for more problems. ChatGPT gives a lot of good problems. But let's keep solving this, right? That was just a word of advice. It has nothing to do with the problem. But right now, we know that secant squared is equal to 1 plus tangent squared of x. This is the trigonometric Pythagorean identities. And we can actually distribute the secant squared into this parentheses. So secant squared times 1, and secant squared times the tangent squared. Well, we can separate this integral into different parts, correct? Because we can separate it, and since there's a difference, there's a term here that separates these two sections of your function. So we have secant to the power of 2. Well, the integral of secant to the power of 2. It's an identity. It's just tangent. Correct? So let's write tangent on the first part. Tangent plus, because we have a plus here. And we just need to solve for the integral of secant squared tangent squared. Well, again, u substitution. Secant squared is the derivative of tangent. So we can set tangent equal to u. And we can set du equal to secant squared of x dx. So therefore we can set dx equal to secant squared of x. Du over secant squared of x. Alright, so let's go ahead and replace everything. We have secant squared of x. And tangent is simply just u squared. Dx is equal to du over secant squared of x. Alright. Secants cancel out. So all we get left off with is the integral of u squared. The integral of u squared is just u to the power 3 over 3 plus c, of course. Oh my god, did I forget to put a plus c in the last problem? Wait, I'll just look back on that and I'll put plus c in the notes. But what we do here, u is equal to tangent. So we have tangent to the power 3x over 3 plus c as our integral for secant squared tangent squared times tangent squared. Therefore, we have tangent to the power 3 over 3 plus c as the integral for secant to the power of 4. So really, I'm going to emphasize this even more. It just comes down to pattern recognition and practice. So the more you do this, the better you'll get at it. But I really hope that this video helps. This topic is just a practice topic. There's really nothing else you could do about it. So, as always, if you have any questions, put it down in the comment section. And if you found this video helpful, consider subscribing and liking the video. Thanks for watching.